Edexcel C2 May 2009, question 9. It's a differentiated modelling question and it's worth 5, 9, 13 marks. What have we got to do for 13 marks? The usual show that, but we get 5 marks, not the usual 4 for this one. The usual 4 to find the value of r, which gives us a stationary s. 2 marks for proving that it gives us a minimum value of s. And then 2 marks for finding the minimum value of s. Right. So part A, we need a Lincoln equation. What have we got? We've got a sector, which is made into a prism, a right prism with a cross-section of a sector. The sector's got radius r and the angle 1. The sector is equal to sector prism is equal to sector times depth and the sector area is half r squared theta. Theta is 1 times h. That's equal to 300 because we've got the number there, and that gives us that h is equal to 600 over r squared. What have we done to get that? Made h the subject of this one. This is 1, so we can ignore it. 2 times 300 is 600 divided by r squared. And the surface area of our prism, sector prism, is equal to 2 times sector area plus the rectangle which we get when we unravel that wraparound part. So I call that the wraparound. The sector area is half r squared, as we found there, so we're going to double that one. And then the wraparound is r times h, this rectangle here. We've got the same rectangle there, so we've got plus 2 rh's, and then we've got this, which is height of h, and the length of this bit is r theta, but theta's 1, so plus another rh, so that's equal to, those two cancel, so we've got r squared plus 3rh, but h is equal to this, so that's equal to r squared plus 3r, 600 over r squared, and that's equal to r squared plus 1800 over r. What do we want? S is equal to r squared plus 1800 over r. Oh, I think we got it. Part B. Use calculators to find the value of r for which gives s, for which s is stationary. So at a turning point, so we call it a stationary point because they have ds by dr is equal to 0. So we need to ds by dr this one. So that means that 2r. So we could write that as r squared plus 1800 r minus 1s. So times by the power. Let's take away 1800. R to the minus 2 is equal to 0. So let's rewrite that as this one. And if this is equal to 0, then 2r is equal to 1800 over r squared, i.e. r cubed is 900, and r is the cube root of 900, and that's equal to, calculator, cube root 900 equals 9.65. 4893846, and so on. And that's in centimetres. Part C. Prove that this value of r gives a minimum value of s. For min, we know that d2s by dr squared from min is bigger than 0. And so differentiate this one again. So 2, let's write ds by dr, d2s by dr squared equals, differentiate that, is 2 plus 3600 over r cubed, and at r is equal to the cube root of 900 d2s by dr squared is equal to 2 plus 3600 over 900. This is 4 plus 2 is 6, which is bigger than 0, therefore it's a min. And d, find the nearest centimetre squared, minimum value of s, min value of s is equal to, okay, so this is our surface area formula, this one here, and it's a min when r is the cube root of 900, as we've got found there, or here. So min s equals 900 to 2 over 3 plus 1800 divided by 900 to the power of 1, third even, and that's equal to, so 900 to the power of 2/3 plus 1800 divided by the cube root of 900 equals 279.65 centimeters squared. To the nearest centimetre squared is 280. We've got our 13 marks. Fairly standard.